Hi, I'm Yue Yu from Hong Kong University of Science and Technology, HKUST. On behalf of my co-authors, it is my honor to present our paper here. In our paper, we introduce our project that tries to promote food-saving actions on campus, leveraging data visualization and gamification. Food waste is a severe challenge to our planet, and its severity on campus is of particular concern. For HKUST, the monthly food waste on campus is reported to be 45,000 tons. Addressing this issue is crucial to minimize our ecological footprint and promote a more environmentally responsible campus community. In response to this, we try to build a system to make interventions to reduce food waste on campus. We are motivated by a review of food waste reduction interventions. 3 intervention types are introduced: information-based, technological solutions, and policy change. While policy change often requires a substantial transformation in existing infrastructure, we chose to focus on the first 2 intervention types in our project, which are more feasible. Our primary objective is to promote food-saving habits of the university community members and contribute to building a sustainable campus. Therefore, we design one task for each type. The first task is to raise awareness of university members about the severity of campus food waste. The second task is to encourage actions to reduce food waste at every meal. We propose our system, FoodWise, consisting of a data storytelling dashboard and a mobile web application. The dashboard addresses Task 1. It presents data-driven insights to raise food waste awareness among the university members. Concurrently, the gamified web application addresses Task 2 by encouraging users to reduce food waste. The individual efforts are then collectively displayed on the dashboard, creating a positive feedback loop that promotes continued food waste reduction. Now I will focus on the implementation of Task 1, the data storytelling dashboard. Its architecture consists of 4 modules. A video processing pipeline calculates waste statistics captured from the video clips. A database stores data. A backend system handles data queries. And a front-end website visualizes food waste information through a data story. For the algorithm, we collect data by installing a camera on the top of the tray collection station of the university cafeteria. The video processing pipeline uses several pre-trained deep learning models. First, an object detection model trained with the YOLO architecture extracts tray images from the video clips. Then, image segmentation model trained with Deep Lab v3 architecture segments and identifies various types of food waste, including rice, meat, and vegetable. These categories are chosen according to the local food culture. Finally, the areas occupied by each type of food waste on each tray are stored in JSON format in the database. For the UI, we developed 2 web pages that aim to resonate with the audience and capture their attention. The first daily page displays the severity and the type of food waste. We visually illustrate the extent of food waste distribution using 100 bowls, which is a symbolism for food in the local culture. Each bowl stands for 1% of the total meals of that day. The second monthly page shows a stacked bar chart illustrating the changing trend of food waste on campus. This provides a broader perspective on the issue and allows users to track progress over time. To make the dashboard visually appealing on screen, we used animation to enhance the presentation in an infinite loop. Additionally, each page includes food-saving tips to encourage the audience to take immediate actions after watching the data story. For Task 2, the architecture of the web application consists of a database, a cloud storage system, a backend, and a front end. The UI consists of 8 pages, and I will introduce 4 main pages here. The overview page displays individual users' average completion statistics across different types of food. It also provides a summary of the users' statistics compared to the average statistics of all users. This allows users to evaluate their relative standing within the cohort. The middle section of the page displays the badge earned by the users. At the bottom, users can review their past submissions. At the right lower corner, the users can press the button to navigate to the record page. The record page allows users to take a picture after their meals and input how much they completed for each food type. Then the user's record list can be accessed on the history page. Only on the badge page, badges earned by the users are highlighted. There's also a progress bar for each badge indicating the remaining work required to attain the badge. The page also provides information on the number of users who already earned each badge, thereby making it like a competition. The badge wall is a gamification system to maintain user engagement. To make the challenge more interesting, different types and levels of goals were proposed. The attempt badge is awarded for users' first submission. The persistence badge requires users to record actions for several consecutive days, encouraging a daily food-saving habit. Quality and quantity badges motivate users to consistently finish meals instead of making several random attempts for rewards. To claim the final reward, users must earn all of the badges. Social impact and evaluate the real-world effectiveness, we integrated the system into a 2-week food-saving campaign. The reward is a food coupon worth about $60.5, which is sufficient for 1 free meal in Hong Kong. We promoted the campaign through both online and offline channels, and we also show our dashboard on a large digital screen on campus. Eventually, 220 people have registered, 51 won the final awards, and over 800 food-saving actions were submitted. Now I will introduce the evaluation part. We distributed user feedback survey that has 9 questions with the extra lucky draw for the food coupon. We received responses from 53 registered users. Question 1. Over 60% of the respondents agreed the dashboard increased their awareness of campus food waste. However, about 25% of the respondents reported not applying, meaning they have not noticed the dashboard. It suggests the placement of the dashboard could be further optimized for better visibility. Question 2 evaluates the usability of our mobile web application, with over 90% finding the system easy to use. Question 3 asks the issue encountered by the users, and the prevalent issue is the difficulty in uploading photos. In question 4, almost 90% of the respondents reported a sense of accomplishment when earning a badge, suggesting it is effective in motivating users to take actions. Question 5 and 6 measure the impact of the campaign. In question 5, more than 80% of the respondents agreed that the campaign increased their awareness of food waste issues. 65% of the respondents in question 6 reported improved meal planning and food waste reduction skills during and after the campaign. We also explored the potential of conducting similar future food-saving campaign in questions 7 and 8. The response to question 7 showed a strong participant interest in future campaigns, and question 8 revealed the majority of the respondents are willing to invite their friends in such activities. Question 9 is an open-ended question for personal thoughts. The most frequent suggestion is a reminder or notification system for logging food-saving actions. 8 respondents also suggest more flexible reward options. 5 respondents suggested improving campaign promotion and involving more community members. 3 respondents found some goals are too difficult to achieve and call for more personalized goals. Now I want to share some lessons we learned to future organizers who are also planning such sustainability initiatives in a campus setting. For the dashboard, first, it is necessary to consider local food culture. It determines how you formulate your image dataset for model training and how you design your visual elements and user interfaces that are emotionally appealing and align with the local conventions. Second, its location in a busy campus is important. You can place it in high-traffic locations or even at the food ordering counter to ensure its visibility to increase engagement. For the mobile web application, first, the gamification system can be further tailored for diverse user preferences, ensuring broader participation. Second, students usually have busy schedules, so a user-friendly reminder system such as a personalized reminder email is very necessary to maintain user engagement. In conclusion, we introduce FoodWise, a system aiming to encourage sustainable practice on campus, combined with the data storytelling dashboard and a mobile web app. We integrated the system to a 2-week food saving campaign, attracted more than 200 participants. Feedback from 53 users suggested the system's effectiveness and the potential direction for improvement. As we are moving forward, we are trying to integrate the system to policy-level intervention for long-term impact. We also hope to inspire other communities to adopt similar initiatives with the power of computing system and contribute to the global goal of sustainability. And thank you for listening.